Well, welcome to MV Tutors. If you would like a session after this, comment below and ask for one, or you can visit our website and book a session over there. The website, you'll find it under the description of this video. Okay, other than that, we're still on chemistry, and today we are talking about isomers. Now, I like to start my sessions with a vision, okay, in mind. And this is the vision right here. The vision is to answer these questions successfully. Okay, we've got question 1 here, which is asking for a functional isomer. And then we've got question 2, which is gonna ask for a chain isomer. Okay, so we'll answer these questions as well. If you can't answer any of these questions, stick around and let's get through it. Hopefully by the end of this session, you will be able to tackle these questions. Okay, so let's start with a bit of theory. What are structural isomers? Structural isomers. Now, these are compounds. Okay, first of all, they are compounds or molecules with the same molecular formula. Form or molecular formulae. There's an R there. So this could be CH3. This is what we call molecular formulae, or molecular formula. So isomers have the same molecular formula, but different structural formulae. Okay, so structural formula is that. Okay, so let's put a H. This is what we call a structural formula. Okay, so they have the same molecular but different structural. Now there are 3 different structural isomers that we are dealing with. Three different structural formulas. Now the first one we're going to discuss is this one, which is called the chain isomer. What makes it a chain isomer? As you can see, they both have the same molecular formula. They're both C4H10. But they have different structural formulae, or rather. As you can see, the structure here is a straight. This one is a butane. This one is a propane because there's 3 carbon atoms. 3 carbon atoms in a row. That's the longest line, okay, of carbon atoms. So that's what we call a chain isomer. Okay, so the chain one, as you can see, straight, but they both have the same homologous group, which is they are both alkanes. Okay, they're both alkanes. And then positional isomer, they both have the same molecular formula, as you can see there. Okay, and then they have the same functional group. They both have the same functional group, and the functional group here is they both have an OH, as you can see over there, and as well as over there. They both have an OH. Now, the difference is that the OH is in different positions. That's why it's a positional isomer. They are in different position. This one, the functional group here is in position 1 on the first one, okay, and then it's on position 2 on this one. So these are positional isomers. They have the same functional group, just in different positions. And then the third one is a functional isomer. As you can see, it has the same molecular formula, okay, but the function is the functional formula are different. So these ones have different functional groups. Okay, so they have different functional groups. So this one is a ketone. What makes it a ketone is that the functional group is at the end. This one is an aldehyde. They made a mistake here. This is not a ketone, it's an aldehyde. It's an aldehyde. It has the same functional group. The same functional group, different homologous series. My mistake. Different functional groups. So the functional group here is such that it's an aldehyde, and the difference between an aldehyde and a ketone, I've done a video on this, is that the functional group of a ketone is on the last. It's on the last carbon atom, whereas the aldehyde, it's somewhere in the middle. Okay, as you can see from here, it's somewhere in the middle. Anywhere in the middle, then it makes it an aldehyde. If it's at the end, then it becomes a ketone. Okay, so this is a functional isomer. Same molecular formula, different functional groups. Okay, so this is different functional groups and different homologous series. This is a ketone, that's an aldehyde. That's it. Okay, let's use the information we just learned to answer these questions. Now, the question says, which one of the following is a functional isomer of butanoic acid? So it's a functional isomer. And remember, a functional, we spoke about it, that it has a different functional group. Okay, so for example, here, butanoic acid, we need to know how to write that. Butanoic acid is, but is 4 carbon atoms. Okay, and what makes it a butanoic acid is that the functional group for a butanoic acid is such that it's got an O there and an OH. Okay, so COOH. This is a butanoic acid. Okay, now the different functional group is that of an ester. This is a functional group which has the same molecular formula. An ester has the difference between an acid and an ester is that an acid, the functional group is at the last carbon atom, whereas for an ester, it's somewhere in the middle. So the O would be here, and then you'd have another C like that, and then a C H. How many of them? Could be 3 of them. It's 3 of them. Okay. Now remember, each one of these has an H here because Carbon must always have 4 bonds, like that. Okay. Now, this is a different one. Okay, so now when we come up here, we are looking for something that is similar to this, an ester. We're looking for an ester. So is A an ester? The functional group is somewhere, it's on the last C, so that's not an ester. Let's go to B. There we go. Functional group is somewhere in the middle, and then we have a CH2 and then a CH3, just like here, what we drew here. Okay, so B is our answer over here. Okay, we don't need to look at the rest because we've already found our answer. Let's not waste time. Okay, let's do the next question. Now this one says consider the organic compounds A to F. All right. Question says write down the letter that represents a compound that has a carbonyl group. Okay, so what's a carbonyl group? We know a carbonyl group is a group like this, COO group. All right, so we're looking for a COO. A, COO is not there. B, COO is not there. C, COO is not there. D, COO is not there because it's an alkane. E, COO is right there. There it is. Found it. So our answer here is E. Okay. And then says it has is an alcohol. An alcohol, it has an OH group. So we start again. A, an OH is not there. B, OH is not there. C, we have an OH right there. Okay, so our answer is C. Then it says is a chain isomer, okay, of that. Okay, now if you remember what a chain isomer is that they have the same homologous series, meaning if they're alkanes, they're all alkanes, such as this. This, what we can notice here is that this is an alkane actually. Okay, it's only single bonds between C and H. Okay, so it's an alkane. So here we'll be looking for an alkane. Let's start again. A is not an alkane because it has a double bond. So that's an alkene. B is not an alkane. It's an alkyne because it has a triple bond over there. Okay, C is an alcohol because it has an OH. D, we look at the last suffix. Okay, the suffix of an alkane is ane. Okay, so just from the word alkane. So because this one, D, has an ane in there, that makes it our final answer. Okay, well, we can confirm with the rest. E is not, it doesn't have, it's not an alkane. And F, let's look at F. F is not an alkane either. Okay, so D is our final answer. All right, thank you so much. We are done.